Hey everyone, this video is going over the 1.5 classroom homework assignment. There's never really class time to go over it, so I thought, for those of you that really need it, I'm going to explain to you everything that was on this. And for more detailed explanations, look at the 1.5 notes, okay? Because it would take a really long time to work things out as I'm doing it. So I worked it out beforehand, and then I'll just explain to you what I did. Okay, so always make a two-sided equation if all you have is absolute value of this equals something else, or less than, greater than. So I put a 4 on one side, I put a -4 on the other. If there's any math to do, I would do that, but if there's just an x in the middle, so the answer is done. So if your inequality symbols are pointing to the left, that means x you can shade in the middle. That means x is in between -4 and 4. And then you put open circles because the inequality sign was not underlined. So for number 2, the answer is no solution, because no matter what you plug in, it's always going to output a positive number. See, all I have is absolute value of 2x minus 9. I'm always going to get a positive. Whether I plug in a positive or negative value for x, it'll always output a positive number. So I'll never hit -8. There's no intersection there, so it'll never be less than it. It'll always be greater than it. So that's why it's no solution on that one. For number 3, I made it the two-sided equation through 2 on the right, -2 on the left. So I had a -8 to each end, and I got k is I guess less than -10 but greater than -6. So if they're pointing to the right, it's not in between them. It's an or statement, okay? You have to split it up and make an or statement. And so just write it from k's perspective. K is going to be less than -10, looking at it from this way. Or you can say that k is greater than -6. So because it's split up like that, it's shading in the opposite directions. And these are open circles again because the inequality signs were not underlined. Okay, let's look at number 4. So on number 4, it is y minus 4, absolute value of that, is less than or equal to 8. So I made it a two-sided equation, or inequality I should say. So -8's on the left, +8's on the right. I have to add 4 to each end. And so this one, both inequality symbols are pointing to the left, so I don't have to make it an or statement. It's technically an and statement, so if it's an and statement, you can write it together. -4 is less than or equal to y less than or equal to 12. In other words, y is in between -4 and 12, so that's why you shade it in the middle, and you have closed dots instead of open dots because that inequality symbol was underlined for that or equals to option. All right, moving on, let's look at number 5. Number 5 is all real numbers because it is greater than a -2. So on the other one, I said it was no solution because it was less than a negative. Well, if you're always going to output a positive number, then you're always going to be greater than a negative, so it's always true. So no matter what you plug in, you'll get the right answer. You'll get an answer that's true. So that's why I wrote all real numbers. All right, let's look at number 6. So on number 6, you see the inequality sign is pointing to the right, and so that's why I have a little bit more work shown here. But make it a two-sided inequality. So 7 is on the right, -7 is on the left. Both inequality symbols are pointing to the right, so when you're going to -4 to each end. All right, so that gets you 3c and then you have -11 on the left and +3 on the right. So you have to divide everything by 3. So -11 over 3 gets me some decimal. I can just leave it as a fraction. So I wrote -11 over 3 is greater than c, which is greater than 1. So they're both pointing to the right. So it means you need to split it up and make an or statement, writing it with the letter C coming first each time. So if you get confused on this, look, it is pointing to the C in this case. So when I write it again, it's still pointing to the C. So C is less than -11 over 3. Or, and see how it's eating the C on this end, C is greater than 1. So the inequality symbols are not underlined. So open circles and shade on the outside. Okay, so let's look at number 7. Number 7 is no solution because it's less than a negative 8. You're always going to be greater than a negative. As if all you have is absolute value bars of something, it's always going to be greater than a negative. So that's why it's no solution again. Let's look at number 8. So number 8 is probably the most confusing one on here, and so I'll do my best to explain it in the least confusing way possible. It starts off kind of normal. You have to minus 8 from each end. All right, and so that gets me negative 13 on one end and negative 3 on the other. So when you divide by a negative number, you have to flip everything. So you flip the inequality sign. So first of all, this makes a positive 13 over 3. See, positive 13 over 3. This makes positive 1, so I wrote positive 1. And so I flipped my inequality sign. Because when you divide by negative, you have to flip the inequality sign. And so when that happened, you actually need to flip the numbers from each end, because I didn't change anything. See how it's, like, I didn't, like, make anything different. See how it is saying R is, that's less than negative 13 over 3? See, R is less than negative 13 over 3. And then R is greater than 1. Over here, R is greater than 1 still. So the reason why I had to flip it like that is because 1 is a smaller number than 13 over 3. So you have to put the smallest number on the left and the biggest number on the right. So that dividing by a negative kind of, you flip basically everything. If you think about it, you flip the signs, but then you flip the order. So yeah. So the graph is pretty normal now. You got a shade in the middle because they're both pointing to the left, and open circles because the inequality symbol is not underlined. All right, let's look at number 9. So number 9, I have some stuff on the outside of the absolute value bars. So you need to take care of that stuff first. So the first thing to do is always look for something you can add or subtract. Don't worry about that 1/3 yet. Get rid of this minus 1. So I have to add it to the other side. So when I add it to the other side, I get 9. And so here I wrote times 3, because if you're trying to get rid of a fraction, flip it and multiply it to both sides. So the flipping 1 over 3 is 3 over 1, or just the number 3. So I'm multiplying 3 times 1/3, that cancels on the left, and 9 times 3 gets me 27 on the right. So now I have the absolute value of 2x plus 3 is less than or equal to 27. Once you get it to the absolute value of something is less than, greater than, equal to, whatever, a number, then you can make your two-sided inequality. On all the other problems, we started at this step right here. So that's why I immediately went to the two-sided inequality. But I didn't do that on this one because I had stuff on the outside first. You need to take care of that outside stuff first. So anyway, make a two-sided inequality from this step. So throw a negative 27 on one end and 27 on the other, and then minus 3 to each end. You get negative 30 on the left and positive 24 on the right. So that means you have to divide everything by 2, and when you do that, you get negative 15 on the left and 12 on the right. Your inequality symbols are pointing to the left, so that tells me x falls in between negative 15 and 12, which means I get to shade in the middle, and I put closed dots because those inequality symbols were underlined. All right, so that's all I have to say about number 9. Let's do number 10. So number 10, it's a little different because I want you to describe and correct the error that somebody made while solving this absolute value inequality. So they solved it like they did the arithmetic correctly, where they did x plus 2 is less than negative 3. They showed their work a little bit differently than I do since I make the two-sided equation. But if you put it on the other end, like, let me show you what I'm talking about. If I write x plus 2 less than negative 3 and then less than positive 3, looking at it like this, 3 is less than x plus 2. They wrote x plus 2 is greater than 3. So that's what this is. So they just showed their work a little differently, but they did their arithmetic right. So what was the mistake? The mistake was that it was no solution. They shouldn't have done any work at all because it's less than a negative, and you're never going to be less than a negative if all you're doing is taking the absolute value of something. So that was the mistake they made. Okay. I hope this helped. Stay tuned for additional videos going over other assignments, and let me know if you have any questions. Goodbye, everyone.